Hello, good morning everyone. Today we are going to discuss one of the most important SQL statement, that is select statement. In the last session we have covered DDL statements and also we have covered 3 DML statements. Those are insert, delete and update. I hope you have understood and you have practiced those statements so far. In this session, we are going to focus upon the fourth DML statement, select. As I stated earlier, select statement is being used to manipulate, to retrieve the data from the database. And we are having various variants under select statement. So we are having different clauses, those we may use under select statement. So to begin with, let us focus upon the basic structure of this SQL query statement, select. So by means of this select statement, we are providing a query to extract or retrieve the data from the database. So a typical SQL query is having the form select list of attributes, those we would like to extract from the set of relations from which we would like to extract the data, and we are having where clause in which we provide the predicate P. I'll repeat, for the basic form of SQL query, we are having these three important constructs. So we are having the construct like select, then we are having from and where. Okay, so how we write the query in SQL, select, then the list of attributes, those we would like to extract. So AI represents the attribute, from the list of relations from which we would like to extract the data. So Ri represent the relation where P is the predicate. Right? So this is a general basic structure of SQL query statement. And this query is actually equivalent to the relational algebra expression. So this same query in SQL is equivalent to this relational algebra expression, wherein we are writing the query like projection operation, list of attributes, then selection operation with predicate P, and we are working on the relations R1, R2 up to Rm. In parenthesis, we are finding out the Cartesian product of all those relations R1, R2 up to Rm. On these relations, we are providing this predicate P by making use of this select statement in relational algebra, and then we are extracting the required attributes A1 up to AN using the projection operation in relational algebra. Right? So these two are equivalent. So if I give you such kind of a query in relational algebra, and if I ask you to write the equivalent SQL statement, then you should be able to write the equivalent statement like this. Right? So I hope you must have understood this basic structure of SQL query.
Yes, ma'am.
So what is the basic form of SQL query? Which are three important clauses that we should have?
Attributes, relation, predicate.
Select clauses I am talking about. So we should have select from,
Yes, ma'am.
and where. In fact, this where clause is optional. This where clause is optional. Right? If we want to provide the predicate, then only we are making use of this where clause. But select and from clauses are mandatory for every SQL query. In select, we are listing out the attributes. In from clause, we are listing out the relations. And in where clause, we are providing the predicate if required. And this SQL query is equivalent to the relational algebra query that we have discussed earlier. Right? So let's proceed. Simple queries, queries on single relations. Right? So we are having the select clause that lists out the attributes, those we would like to extract. So the select clause in SQL query is equivalent actually to the projection operation in relational algebra. In projection operation in relational algebra, we list out the attributes, those we would like to extract. Similarly, in select clause of SQL, we list out the attributes, those we want to extract. Right? So this select in SQL is equivalent to the projection operation in relational algebra. Please remember. Right? So let us assume that we would like to find out the names of all departments in the university. So we are explaining now, as I stated earlier also, all the SQL statements we are referring to our university database, and we are going to write the SQL statements for our university database. Right? So let us assume that we would like to find out the names of all departments in the university. So we have stored department data in the relation department. So we want to extract the data from department relation or department table. And what we want to extract? We want to extract names of all departments. So only one attribute we are interested in. And that is why in select statement, we are having here department name listed. So we want to visualize all the department names. So select department name from the relation, that is department. So this is how we can provide the query in SQL to extract department names from department table. Right? Are you getting me?
Yes, ma'am.
Yes, ma'am.
Fine. See the equivalent relational algebra statement as well. Okay. So in pure relational algebra syntax, the same query can be written as the projection operation. The attribute that we would like to extract is department name, and the relation from which we want to extract the data is department. So these two statements are equivalent. This is written in structured query language and this is written in relational algebra. Right? So we are going to compare now this SQL statement and relational algebra statements. Right? As I stated, relational algebra is the basis for SQL. Okay, so similar statements we are having, we can write in relational algebra and also equivalently in SQL. Okay, for practical purposes we are using SQL. So let me show you how this statement can actually be executed. Right, so let me share. Whether my screen is visible? Yes?
Yes, ma'am.
Okay. So see here how we can execute that statement practically. So I have inputted all the data in the respective tables. In the last session, I have demonstrated how to use DDL statements and create the schema. Right? We are using Oracle, and also I have explained you how to input the data using insert statement in all those tables. Right? So I am having all the database available with me now. Okay? So suppose I want to extract department names from department table. So this is the statement that I am using. Select department name from department. Right? So if we run this statement, we'll be getting all the department names that we have presently in our database. Right? Got it?
Yes, ma'am.
Fine. So let's proceed now with few more statements. Find the names of all instructors. So how we can write this statement in SQL? Select. Name is the attribute that we would like to extract from instructor. So simple it is. Right? Let us try one more. Find the department names of all instructors. Find the department names of all instructors. So what happens here is, if we give the statement select department name, what we want to extract? Department name of all instructors. So we are having in instructor table the attributes like ID, name of the instructor, we have department name of the instructor and salary of the instructor in instructor table. And what has been asked for? Find the department names of all instructors. Right? So we want to find out the department name from instructor table now. Okay? So we are having the statement select department name from instructor. Right? So what we will get is, we will be able to see all the department names. Right? Those belong to the instructors. But please see here, if we provide such kind of a statement, what will happen? That it may happen that we are having more than one instructors from same department. Right? So the duplicates in the relations are still been visualized if we provide such kind of a statement. So if I am having 10 instructors, those belong to computer science department, then computer science department will be visualized 10 times. Okay? So if we want to remove those duplicates, so actually SQL allows the duplicates in relations as well as in the results of SQL expressions. But if we want to remove those duplicates, what needs to be done is, we need to add one more keyword, and that is distinct after the select statement. Right? To forcibly eliminate the duplicates. So this statement can be provided by removing the duplicates like this. Find the departments of all instructors in instructor relation and remove the duplicates. So to remove the duplicates, we are providing the statement like select distinct department name from instructor. So the new keyword that we are introducing here is distinct. So this distinct keyword will give us the department name only once. So duplicates are being removed. Right? So many times we may need to use this distinct keyword. Okay? But if we want to forcibly, by default, if we do not use distinct keyword, then department names, if they appear more than once in the table, then all those department names will be displayed. If we want to forcibly show the duplicates in the table, then we are having one more provision in SQL, and that is this keyword all. So the keyword all specifies that duplicates are not been removed. So alternatively, we may provide the statement like select all department name from instructor. So this all keyword will not remove the duplicates, whereas this distinct keyword will remove the duplicates. So this is equivalent to actually the default statement, that is select department name from instructor. Right? In fact, the outputs of these two statements are same. But please remember, we are having this additional keyword all that will forcibly provide us the duplicates. Distinct will remove the duplicates. Right? Fine. Now, let us try to practically see how we are getting these results. Okay? So, what we want, suppose we want to, first of all we'll see, we want to display the names of instructors. So select name from instructor table, and if we execute this statement, we are getting all the names of the instructor. Right? Getting me? If I am having more than 10 tuples and if I want to visualize those tuples, here we are having the setting in Oracle how many tuples to display at a time on the screen. So by default 10 tuples from the table are being displayed, but we may change this setting. So if I want to display 20 tuples at a time, it is possible for me. And see here 12 instructions. We are having all the department names listed, and see here by default the duplicates are not eliminated. So computer science appears here once, twice and thrice. So 3 records, 3 instructors we have from computer science department. So 3 times that computer science department is being displayed here. Right? We are having more than one instructors from physics department as well. So physics also appears once and twice. Right? So duplicates are not removed by default. But if we want to remove the duplicates, what we need to do is we need to write this statement with distinct clause. So select department name from instructor. So if we execute this statement, see here each department appears only once. So we have removed the duplicates by making use of this distinct keyword. Right? And as I stated, we are having alternative to this by making use of explicitly all keyword. So select all department name from instructor. So if we execute this statement, once again we'll be getting all the department names without eliminating any duplicate. Right? Are you getting me? Yes?
Yes, ma'am.
Yes, ma'am.
May I proceed?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Fine. So let's proceed now. So we are having now one more statement that denotes the use of this asterisk. Right? So an asterisk in the select clause denotes all attributes. So far, whichever select statements those we have used, we have listed here a single attribute to be displayed. To display all the attributes from a particular relation, then we may use this asterisk. So asterisk denotes all attributes. Right? So select star from instructor statement will provide us the list of all instructors along with all the attributes those are stored in the instructor table. Right? Now, this select clause can also contain the arithmetic expressions involving the addition, subtraction, multiplication and division operators operating on the constants or the attributes of the tuples. So let us see one example here. If I am writing the query like select ID, name, department name, salary into 1.1 from instructor. So this statement will return me a relation which is same as the instructor relation except that the salary is multiplied by 1.1. So 10% increase in the salary of each instructor. But please note that if I am using the arithmetic expression in select clause, then I am able to see the effect of that arithmetic instruction, right? I am able to visualize. But this visualization is temporary, meaning this 10% rise in this case is not actually stored in the table. This is a temporary effect that I am visualizing. Right? If I want to permanently increase the salary of the instructor, then which statement should I use? You have seen this earlier. If I want to permanently increase the salary of the instructor and if we want to store the updated salaries in the table, then which statement should I use for permanent effect? If I want to store permanently the updated salaries of the instructors, then which statement should I use? Yes. Which statement? In the
Update.
last, yes, correct. Update. Update statement is actually updating. It is actually storing the updates in the table permanently till we once again modify it. Right? But if we are using such kind of arithmetic expression in select statement, then this is only meant for visualization. Right? We are not at all storing this effect in our table. If we want to permanently store it into the table, then we should use update statement. That is the difference. Correct? Are you getting me? Yes?
Yes, ma'am.
Fine.
Yes, ma'am.
Let's try to implement these statements also. So Let's write this statement, select star from instructor. And if I execute this statement, I'll be getting all the data. Star indicates all attributes. So we are having 4 attributes in our instructor table. So it is possible for me to visualize the instructor table with all its attributes. Right? Please look at this data. So this is the original salary that we have. And now other statement with arithmetic expression just to demonstrate. Right? So what was that statement? We want to use select ID, comma name, department name. And what else we want? We want to visualize the salary of the instructor increased by 10%. We are using the arithmetic expression salary into 1.1. Right? From which table we would like to extract the data? Instructor table. So if I execute, just look at it, these are the original salaries, right? And now we are visualizing the salaries after increment of 10%. So see here, salary multiplied by 1.1, so 10% increase. So as I stated, we are only visualizing this change. We are not at all updating it into the table permanently. So if once again, if I use this select star from instructor, I'll be getting the original data only. Look at this, right? And if I execute once again this statement with modified salary, then I can visualize the salaries. Those are modified, but these are not stored in the table. If I want to permanently store these salaries in the table, then I should use the update statement that we discussed in the last session. Am I clear? Yes?
Yes, ma'am.
May I proceed with the next? Fine. So, let's proceed with the where clause now. Okay? As I stated earlier, where clause is optional. Right? And where clause is being used to provide the predicates or the conditions. Right? So, in fact, this where clause is equivalent to the selection operation in the relational algebra. Right? Where clause is equivalent to the selection operation in relational algebra. In relational algebra, we give, in selection operation, we provide the predicate. And in SQL, in where clause, we provide the predicate. Where predicate. Predicate is the condition that we would like to impose upon. Right? So let us see now the example. Find the names of all instructors in the computer science department who have salary greater than 70,000. Find the names of all instructors in the computer science department who have salary greater than 70,000. So how to write this statement? In SQL, we are going to write this statement like this. Select. What we want to display? Find the names of all instructors. So the attribute that we want to display is name. So find the names of all instructors in computer science department who have salary greater than 70,000. So we need to impose two conditions. And what are those two conditions? The instructor must belong to computer science and the salary should be greater than 70,000. So in where clause, we are providing these two predicates. department name equal to computer science and salary is greater than 70,000. From which table we would like to extract? From instructor table. Right? So select name from instructor where department name equal to computer science and salary is greater than 70,000. So this is how we are going to write our select statement in SQL. Right? Now, please note here, we are making use of here the comparison operations equal to, greater than, we may use less than, we may use less than equal to, greater than equal to, not equal to, and so on. These are the comparison operations, right? And also we may use these comparison results with the logical connectives. So and, or, not are the logical connectives. So we may use, depending on the requirement, we may use these logical operations also, and, or not. Right? And these comparisons can be applied to the results of arithmetic expressions as well. So let us try to implement this statement in SQL practically. Okay, so once again let us switch to Oracle and let us see how we can write this statement. So we are using select statement. What we want to display? Name of the instructor. From which table? Instructor table. Select name from instructor where department name is equal to computer science. Should be greater than 70,000. So before executing this statement, let us first see the data that is stored in instructor table and let us see what we are expecting. So we are expecting names of the instructors from computer science department and who are having the salary greater than 70,000. So what is expected? This person is from computer science but salary is less than, so this should not be included. Cats belong to computer science and salary is greater than 70,000. Yes, so this should be included. Cats. And Brand, he is also belonging to computer science and salary is greater than 70,000. So we are expecting now these two instructors, Cats and Brand, from computer science department having salary greater than 70,000. Do you agree with me? Yes? Fine. So if I execute now this statement, what happened? I'm not getting anything. And what would be the possible reason? Yes, what would be the possible reason? I'm not getting anything, but I'm expecting two tuples. So please see here, we are comparing the department name. So department name equal to computer science. So please look at this, how we have inputted this department name. Com, then full stop, space, SCI, and then full stop. So obviously we need to use here the similar abbreviation. If I omit this space, then also I'll not be getting the result. Right? So we should provide the name exactly similar to whatever we have inputted in our data set, in our table. So if and only if it matches, then and then only we'll be getting the result. Right? So we have corrected now the name of the department. So let's try to run this and we are getting two names. Those were expected. Correct? Got it?
Yes,
Yes,
ma'am.
ma'am.
Is there any doubt so far? Is there any doubt so far?
No, ma'am.
May I proceed?
Yes,
Yes.
ma'am.
Yes, ma'am.
Fine. So let's proceed with next. So we have seen select clause, we have seen from clause, and we have already seen where clause. But so far, whatever are the queries those we are using, those are the simple queries. Those are requiring only single relation, right? Now, one more clause that I am going to introduce here is the between clause. So this between is also the comparison operator. Between. So let us find out the instructors with salary between 40,000 and 70,000. That is, we want to find out the instructors who have salary greater than or equal to 40,000 and less than or equal to 70,000. So we may use this between clause to make it simple, right? So how we are going to write the query? What we want to extract? We want to extract the instructors, names of the instructors. So select name from instructor where salary between 40,000 and 70,000. So here we are using a new clause, that is between. So this is one of the comparison operators. Those we may use in SQL. So between 40,000 and 70,000 means it is greater than or equal to 40,000 and less than or equal to 70,000. So the same statement we may also write like select name from instructor where salary is greater than or equal to 40,000 and salary is less than or equal to 70,000. So these two statements will provide us the same result, right? But if we look at this between clause, this between clause is more simple to use. Instead of providing two arithmetic conditions here, we may use the between clause, right? So let's try to implement these two queries so that you can understand it better. So see here, select from instructor where salary between 40,000 and 70,000. Select name from instructor where salary between 40,000 and 70,000. So let us try to execute this. See here, we are having 4 instructors who are having the salary in this range, 40,000 and 70,000. So if we want to verify, let us look at the instructor table once again. So salary between 40,000 and 70,000. So this first Srinivasan, then this Mozart, then this EISEC, and this Caliphate, right? So these four should be included. So we are having these four instructors. So suppose if we want to add salary attribute also, then we may run this query like select name comma salary from instructor where salary between 40,000 and 70,000. Got it? So we are having these four tuples with us as the result. The same query can also be written as select name comma salary from instructor where salary is greater than or equal to 40,000 and salary is less than or equal to 70,000. If I execute this statement, I should get the same result. Right? So I hope you must have understood how we are implementing these statements. Right? So let me write now the equivalent relational algebra operation for this. So what would be the relational algebra operation for this? Yes? See, try to write the relational algebra operations as well for these queries so that you can practice both how to write relational algebra query and how to write SQL query. So the relational algebra query will look like the projection operation, what we would like to extract name of the instructor, right? So table to be used is instructor, but we are having here the predicate. So if we want to provide the predicate, we need to use the select statement, and the predicate is salary greater than equal to 40,000 and salary less than or equal to 70,000, and which relation to be used? Instructor. Right? Am I correct? So this is the relational algebra query equivalent to this. And this is the SQL statement that we may provide. This is also SQL statement. Is there any doubt so far? Yes? Is there any doubt so far?
No, ma'am.
Fine. So today we have covered how to extract the data with different clauses from a single relation. So far we have used single relation, right? In the next session, we are going to look at how to write queries wherein we need to use more than one relations, right? And in fact, this SQL is very interesting, and as far as your campus, your interviews, your technical rounds are considered, this SQL is having highest weightage as far as database is considered. So you should be very clear with SQL concepts, right? It is really a fun writing the queries in SQL and extracting whatever is required, right? So please concentrate on all different clauses, those we are going to learn under SQL, and this will help you a lot, right, in your professional career as well. So I hope you must have understood whatever we have covered so far under SQL, and tomorrow we are going to focus upon how to extract the data if we want to extract the data from more than one relations, and we are going to look at few more constructs as well. Right? As I stated, while writing the query, have a practice to write the same query in relational algebra also. Right? So that you can practice both the things. Okay, so let's stop today.